In section 6.5, we're going to learn how to use the difference of squares formula. So our difference of squares formula is right here. If you're given an a squared minus a b squared, then it factors into a plus b and a minus b. So basically, difference of squares, it will always start out as a binomial, and they will be perfect squares. So right here on example 1, it's wanting us to, basically it says what binomial factors as 2x minus 3 and 2x plus 3. It's wanting us to FOIL this back out to see what the original binomial was. So 2x times 2x is 4x squared. 2x times 3 is 6x. Now negative 3 times 2x is negative 6x. And negative 3 times 3 is negative 9. To give us 4x squared minus 9. That middle right there canceled. Okay, so whenever we're given a binomial that will fit a difference of squares formula, this is what it looks like. The word difference means minus, so it has a minus sign, and you can basically take the square root of your front term and your back term. Okay, so let's see if our first example, or second example, I guess, fits that. Okay, yes, this is a difference of squares. I can take the square root of y squared, and I can take the square root of 49. The square root of y squared is y. The square root of 49 is 7. So I'm going to draw my sets of parentheses. I'm going to put y plus 7 and y minus 7. And that's all there is to it. Let's try another. I will say your first step in factoring is to always look for a GCF. 9s squared, 25t squared. No, there's not a GCF that we can pull out. So let's see if this fits the difference of squares formula that we just learned. Well, I mean, it's going to, because we're working examples for difference of squares. But what makes this a difference of squares is the minus sign right here, and the fact that I'm going to be able to take the square root of the front and the back. The square root of 9s squared is 3s, and the square root of 25 is 5. So we're going to have something plus something and something minus something, and I just fill in my 3s and my 5. For another example, remember, always look for a GCF first, always. 50 and 2d squared, they're actually both even numbers. I can pull out a 2, and I'm left with 25 minus d squared. So now I'm only worried about the inside and factoring the inside. I'm not worried about that GCF of 2. This is going to fit the difference of squares formula, and so my answer is going to look something like this. Okay, so let's see. Can you take the square root of 25? Yeah, it's 5. Can you take the square root of d squared? Yeah, it's d. Well, now, is there a GCF on this one? It looks like I want there to be one, but there's not. Okay, so what it's going to come down to, I'm going to go ahead and set this up as if it will work, but it's only going to work if there's a minus sign, and yes, there is a minus sign, and if I can take the square root of both of these things. So the square root of 64, x squared, y squared, is 8xy. And the square root of 1 is 1. Okay, so we're looking. Is there a GCF? H to the 4th, 81. No, there's not. So let's see if this is going to fit the difference of squares. Plus, minus, and if we can take the square root of these things, then yes, it will. So the square root of h to the 4th is h squared. And then the square root of 81 is 9. So I have completed the difference of squares formula, except I gotta do one more thing. This is not fully factored, because now that I have done the difference of squares with h to the 4th minus 81, one of my binomials that I was left with, the one in the back, h squared minus 9, is another difference of squares. I'm going to copy that first binomial back down, because it's a sum of squares. There's not a formula for that. Sum means addition. So that binomial doesn't factor any further. But the one in the back, notice there's that minus sign between h squared and 9. And I know that I can take the square root of h squared, and I know that I can take the square root of 9. The square root of h squared is h. Square root of 9 is 3. Okay, so is there a GCF? 4x squared and 9. No, there's not. So is it going to fit our formula? Well, yeah, I mean, I can take the square root of 4x squared and get 2x. And I can take the square root of 9 and get 3. But this is not a difference of squares. This is a sum. It's a sum of squares, but there's not a formula for sum of squares. So it's prime, meaning this doesn't factor. Now, a lot of people are going to want to put that it's 2x minus 3 and 2x plus 3, because they're used to, 4x squared and 9 being a perfect square, and you can do it if it has a minus sign. Why can't you do it if it has a plus sign? Let's see what would happen if we FOIL this back out. 2x squared, 2x times 2x is 4x squared. 2x times 3 is 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is minus 9. Okay, that's not 4x squared minus 9 is not what we had. It was 4x squared plus 9. So that's why, another reason why that would be prime.